All right, diving in. We've got a stack of what-if questions from you guys. You know, Randall Munro, the guy with the crazy ideas.
Oh, yeah, he's great at those. What if? Serious scientific answers to absurd hypothetical questions. Really?
Yeah, exactly. So we're going to try and do the same thing. We'll try not to get too lost in the science-y weeds, but
Well, that's the fun part.
true. We've got some pretty wild topics, like super hot stuff, space stuff, even some weird things that could happen right here on Earth.
It's always interesting to see where these thought experiments lead. You know, what happens when you really push everyday ideas to the extreme.
Absolutely. And that's what this deep dive is all about, exploring the science behind these crazy what-ifs and hopefully giving you a few of those aha moments.
You know, those moments where you suddenly understand something in a new way.
Right. So to kick things off, how about we jump into a question about extreme temperatures? This one kind of made me laugh. What if you took a sip of hot coffee after being like really, really cold? Like, would your teeth shatter?
That's a good one. It sounds funny, but it actually brings up a real scientific concept called thermal shock. Basically, if something goes through a huge and super fast temperature change, different parts of it can expand or contract at different speeds.
Oh, okay.
Yeah, and that creates stress inside the material. And if that stress gets too big, well, things can break.
Like if you pour boiling water into a freezing cold glass and it cracks.
Exactly. That's thermal shock in action.
So, about those teeth.
Yeah.
Monroe says, for your teeth to actually shatter from hot coffee, the temperature difference would have to be insane.
Yeah, we're talking about a difference you'd never experience in real life.
Like your teeth would have to be close to absolute zero and then boom, boiling hot coffee.
Right. It's just not realistic.
So thankfully our mouths don't work that way.
Thank goodness for that. Our bodies are much better at regulating temperature than that. Heat just can't transfer that quickly inside our mouths.
That's good to know. So while thermal shock is a real thing, that coffee scenario is more of a thought experiment to get us thinking.
Totally. It makes you consider what happens to things under those crazy conditions, even if they're not exactly possible.
Okay, so let's stick with this whole temperature thing for a second. Another question we got was about a chainsaw. Needing to be at a specific temperature to instantly cauterize injuries while cutting. Pretty gruesome, right?
Yeah, it's a bit out there. But what's interesting is that it tries to combine two totally different processes. Cutting, which is mechanical, and cauterization, which is biological.
Right, and cauterization uses heat to seal off blood vessels.
Exactly. It stops bleeding and helps prevent infection. But with a chainsaw?
I mean, it's like some kind of crazy surgery.
Yeah. Yeah, you could say that.
Monroe points out how impractical and dangerous that would actually be, though.
For sure. A chainsaw hot enough to instantly cauterize would be, well, really, really hot. Like insanely hot.
Talk about a fire hazard.
And it would probably cause way more damage than a regular cut. Plus, keeping it at that exact temperature while it's spinning so fast?
Impossible.
Pretty much.
You need so much energy to heat it up, and controlling that heat would be a nightmare. So the chainsaw cauterization thing, not happening.
Nope. But it's a fun way to think about the effects of extreme heat, I guess.
All right, let's switch gears and head out into space. One question you sent us was about building a new star with, well, just what we know and what we have right now.
Now that's ambitious.
Right. Sounds like science fiction.
It does, but it makes you think about how stars actually work. You know, like our sun, it's powered by fusion.
Right. Hydrogen atoms smashing together to make helium.
Yeah, and that happens deep inside the sun's core where it's crazy hot and under immense pressure.
And Monroe really breaks it down, explaining how much energy you'd actually need to make that happen.
It's mind-blowing, really.
We're talking about an insane amount of hydrogen, like more than we could ever get our hands on. And then the energy. Forget about it.
He compares it to setting off a ridiculous number of hydrogen bombs all at once just to get the fusion started.
Which, obviously, we're not going to do.
No, definitely not. Plus, even if we had the fuel, keeping that super hot, super dense stuff contained is way beyond anything we can do right now.
So building a star, not going to happen anytime soon.
Nope, we're just not there yet. But understanding how stars work is a huge step, even if we can't build one ourselves. It shows the difference between what we can do and the amazing power of the universe.
Totally. It puts things in perspective. All right, let's stay in space for a bit. Another question we got was about shining a ton of lasers at the moon.
Ooh, trying to make it brighter.
Yeah. Like, what if we used everything from those little green laser pointers to those super powerful lasers they use in research?
Yeah.
Could we light up the whole moon?
Hmm, that's a really interesting question. At first, you might think, yeah, just keep adding more lasers and it'll get brighter and brighter.
Right, more light equals brighter moon.
And if you just used a few weak lasers, you'd see a tiny bit more light on the spot you aimed at.
But the moon is really far away.
Exactly. And that's where the inverse square law comes in.
Oh, right, the farther the light travels, the more it spreads out.
Yeah, so even with a bunch of those little green lasers, you wouldn't see much difference from Earth.
You need like a zillion of them.
Pretty much. But
Ah.
then it gets really wild when you start talking about those crazy, powerful lasers, the megawatt ones, or those 500 terawatt NIF lasers.
I remember Monroe talking about those. They're insane.
They are. And at that level of power, you're not just lighting up the moon, you're vaporizing it.
Whoa, seriously.
Yeah, those lasers would blast the rock with so much energy, it would basically turn into superheated gas and dust.
Wow, so instead of a brighter moon, we'd have a smaller moon.
Well, eventually, maybe. But first, you'd see these huge plumes of stuff shooting off the surface. It's crazy to think about the power those lasers have.
Definitely. Okay, let's bring things back down to Earth for a bit. One question that really caught my attention was about stopping a volcano eruption with, get this, a bomb.
A bomb, wow.
Yeah, like a really big one, like a thermobaric bomb, or even a nuclear bomb,
Hmm?
like something out of a disaster movie.
That's intense.
I know, right? But does it make any sense scientifically?
Well, the short answer is no. Monroe's pretty clear about that.
No way to stop a volcano with a bomb.
Think about it. Volcanoes are driven by these massive forces deep inside the Earth.
Right, all that molten rock, the magma pushing its way up.
Yeah, and it's under immense pressure. So even a huge bomb wouldn't really do anything to stop that.
It wouldn't even make a dent.
Probably not. And it could actually make things worse. Imagine a bomb shattering the rock around the magma.
Uh-oh. New pathways for it to escape.
Exactly. You could end up with an even bigger and more unpredictable eruption.
And a nuclear bomb. Don't even get me started on the radiation.
Yeah, that would be a disaster on top of a disaster. So, yeah, bad idea all around.
It definitely shows how powerful nature really is. Okay, let's lighten things up a bit. We also got a question about the logistics of raising an army of apes.
An army of apes, that's a new one.
Can you imagine the paperwork?
Just thinking about it makes my head spin. You'd need a ton of resources just to feed and house them, let alone train them.
And apes aren't exactly known for following orders.
Plus, their communication, their social structures, it would be a complete mess.
Probably not the most reliable troops. Okay, this next one is a little out there, even for us. Someone wanted to know how you tell the difference between humans with wheels and the ability to fly and, well, airplanes.
Wow. I mean, where do you even begin with that?
I know. But it's kind of a fun thought experiment.
It is. It makes you think about how different those things really are.
Airplanes are designed to fly. Humans, not so much.
Exactly. And putting wheels on a human doesn't magically make them an airplane. The whole idea is pretty ridiculous when you get down to it.
Okay, let's move on to some questions about the human body under, shall we say, unusual circumstances. One that stood out was about the nutritional value of the average human body.
Oh, that's getting a little dark.
I know, it's kind of morbid. But the question was more about the science. Like, how many calories are in a person? What kind of vitamins and minerals?
I see. So it's less about cannibalism and more about the human body's, well, fuel.
Right. Like any other living thing, our bodies contain energy and nutrients. But thankfully, the source material doesn't go into too much detail.
I'm good with that.
Another question was about crying. Could you actually cry so much that you dehydrate yourself?
Interesting. Well, we all know that feeling of crying a river, right?
Totally. But
Oh.
is it actually possible to lose that much fluid through tears?
Probably not. I mean,
Okay.
tears are mostly water and salt, but the amount you lose when you cry is pretty small compared to the total amount of fluid in your body.
Right. Our bodies are good at keeping things balanced.
Exactly. You'd have to cry nonstop for a really, really long time to get even close to dehydration. And that's just not realistic.
Okay, phew. Now, this next one's a little more complicated. What happens if there's a toxin that blocks reabsorption in the nephron tubules of your kidneys but doesn't mess with filtration?
Whoa, that's getting into the nitty-gritty of how our kidneys work.
Right. Remind me, how do those nephrons work again?
Okay, so basically, nephrons are these tiny filters in your kidneys. They clean your blood. Think of it in two steps. First, filtration. Like a coffee filter, it catches all the waste and extra water from your blood. Then, reabsorption. This is where your body takes back the good stuff it still needs, like water, glucose, and electrolytes.
It's like filtering, then sponging back up the good stuff.
Exactly. But if something blocks that reabsorption,
Uh-oh, you're losing all those important things.
yeah, and a ton of water too, it would be like constantly peeing out all the good stuff your body needs.
That sounds really bad.
It would be. You'd get super dehydrated, your electrolytes would go haywire, and your kidneys would probably fail pretty quickly.
Yikes. That's scary.
It is. Monroe mentions needing a decision in that situation, which probably means you'd need serious medical help, like dialysis, to keep your body going.
I see. All right, let's move on to something a bit less intense. How about this? How long would it take a Venus flytrap to de-juice and absorb an entire person?
Oh, wow. Now that's a visual.
Right. A bit gruesome, but kind of funny, too.
Monroe's answer is pretty hilarious. He says it would take around 7 years, assuming the person is chewing gum.
7 years. With gum.
Yep. It's obviously a joke, highlighting how ridiculous the question is. I mean, Venus flytraps are tiny, they eat insects, and even that takes a while.
So no chance of a human eating Venus flytrap anytime soon.
Definitely not.
Okay, let's switch gears again and talk about sound. A listener was convinced that there is sound in space.
Oh, that's a common one.
Is it really? What's the truth?
The truth is there isn't sound in space. The source material says it perfectly. There isn't, right?
So all those spaceship battles and explosions we hear in movies,
Totally fake.
no epic sound effects in real space.
Nope. Sound needs something to travel through, like air or water. Space is basically a vacuum, meaning there's almost nothing there.
So in reality, those battles would be completely silent.
Exactly. Silent and spooky.
All right, just a few more questions to wrap things up. Here's a fun one. Could you create a tornado by spinning Thor's hammer, Mjolnir, really fast?
Ha! That's a good one. But sadly, the answer is no. Monroe is pretty straightforward about that.
No Mjolnir tornadoes.
Nope. Spinning anything creates air currents, but tornadoes are on a whole different level.
Right. They're caused by all sorts of things in the atmosphere, like temperature differences and wind shear.
Exactly. It's not something you could create with a hammer, no matter how magical.
Okay, one last question before we go. This one's a bit strange. What about the suction power of a lifetime's worth of kissing, all concentrated into one single kiss?
Wow, that's creative.
Right. I'm not even sure how you'd measure that.
Me neither. I mean, kissing does involve a little bit of suction, but to think about storing it up over a lifetime and then unleashing it all at once,
That's a lot of suction.
way too much. It's just not a realistic concept. It's more of a fun, imaginative idea than anything else.
All right, well, that about wraps it up for our What If deep dive. We've covered a lot of ground, from exploding teeth to silent space battles to the impossible dream of building our own star.
It's amazing how much science you can learn from thinking about these crazy questions, right?
Absolutely. What If reminds us to stay curious and explore the possibilities, no matter how absurd they might seem.
It encourages a playful approach to science, but it also highlights the limits of what's possible.
And ultimately, that's what makes it so interesting. So to our listeners, keep asking what if, and never stop exploring the world around you. You never know what incredible discoveries await.
Keep those what-ifs coming. Those seemingly simple questions are often the ones that lead to the most fascinating insights. What might seem like a ridiculous premise today could unlock new scientific understandings tomorrow.
Until next time, happy exploring.